Okay, so we will start by this first problem. So what is this problem? The statement of this problem is you need to show that this vector field f, which is looks like this: e की power x cosine y plus y into z I cap plus x into z e की power minus e की power x sin y j cap plus xy plus z k cap is conservative by finding a potential for it. So what do you mean by saying conservative? We say a field, vector field is to be conservative when you can find a scalar potential for it, right? So now how to find the scalar potential? So first you need to assume that there exists a scalar potential, and that scalar potential is a function of the three variables, the three space variables x, y and z. Now what we will assume? You will assume that since f is the scalar potential and these are the coefficients of f, then the first derivative of the derivative of f with respect to the space variable x will be equal to this term. The derivative of f with respect to y will be equal to this term, and the derivative of f with respect to z will be this term. Okay, so now this symbol means del f del x. So you observed that del f del x is equal to e की power x cosine y plus yz. F y del f del y equal to xz minus e की power x sin y, and del f del z equal to xy plus z. Now you have del f del x equal to this. So now you need to integrate this fx with respect to x. So if you integrate this fx with respect to f, what you will get? You will get simply the function f, and in the right hand side similarly you need to consider the integration, and in the right hand side also if you consider the integration, it will be e की power x cos y plus yz. If you integrate you will get plus xyz, and then since you are integrating with respect to f, instead of constant here you will get a function of y comma z. Why? Because see, if you take this partial derivative of this function f equal to e की power x cos y plus xyz plus gyz, then the first partial derivative will be e की power x cos y, second you will get yz, and from third if you take partial derivative with respect to x you will get 0. So that's why instead of the constant we have considered this function gyz, because we are integrating simply partially with respect to x. And then what we have to do? See, your f is e की power x cos y plus xyz plus gyz. You differentiate it with respect to partially with respect to y. Then from this function what you will get? You will get fy, and this fy will get minus e की power x sin y plus xz plus del g del y yz. And from this here we have observed this fy is equal to xz minus e की power x sin y. So what we got? We got gy y comma z is actually 0. So what does it means? That means that this gyz is independent of y, and this will be independent of y. Then that means that will be just function of z only. Next you consider gyz as hz. If you consider gyz equal to hz, then your f becomes f equal to e की power x cos y plus xyz plus hz. Now you differentiate with respect to z. If you differentiate with respect to z, you obtain fz equal to xy plus dh dz, and what is equal to? This is equal to, you have from here xy plus z. Here xy cancels out, so your h prime z is z. So your hz will be just, you need to into integration, you will get z square 2 plus k. this z square by 2 plus k. So what will be your, this fxyz will be e to the power x cos y plus xyz plus z square by 2 plus k. So the if m and p are functions of xyz on a domain D in space, then the expression mxyz dx okay. So this becomes fxyz equal to e to the power x cos y plus xyz plus z square by 2 plus k. And if you consider m and p are functions of xyz on a domain D in space, then the expression mxyz dx plus nxyz dy plus pxyz dz, this is called a differential form. The differential form is called exact if there exists a function fxyz such that mxyz equal to del f del x, nxyz equal to del f del y, and pxyz equal to del f del z. This is a necessary as well as sufficient condition. Okay. So these type of things are called differential equations. Okay. So that if the differential form is exact, so if you can write this mxyz dx plus nxyz dy plus pxyz dz equal to df. If it is an exact differential, in this case this integration of a to b, line integration of f to b, m dx plus n dy plus p dz will be just the difference between the functional form at the point b minus the function at the point a. Therefore the differential form is exact if and only if f equal to mi plus nj plus pk, this is conservative, then the scalar function fxyz is the potential of the field f. Okay. So so there is a one problem. Will you solve it so that the differential form y dx plus x dy plus 4 dz is exact? So what to showing exactness, what you have to do, you need to find the scalar potential, right? So I will not use this methodology, I will just use the scalar potential thing. So here m is equal to y, n is equal to x, and z p equal to 4. So this is differential equation is exact. So how you can prove it? The proof, see, from y dx plus x dy, you can write it as d of x comma y plus 4 dz, you can write it as d of 4z. So that means the scalar potential is xy plus 4z. If you got, see, the scalar potential is xy plus 4z. There is a constant, it has any role? No role. So this integration, see, y dx plus x dy plus 4z from this point 1 1 1 to 2 3 minus 1. So this will become xy plus 4z plus k, and then 1 1 1 to 2 3 minus 1. So your answer will be, so xy plus 4z at the point 2 3 minus 1 minus xy plus 4z at the point 1 1 1. So what will be your answer? Your answer will be 5, sorry, 2 3 minus 1. So from here you will get 2, and then there that will be total 5. So 2 minus 5 will be minus 3 will be your answer. Okay. Next we will, I hope that this problem is clear to you. Next, it is a very important concept that is called Green's theorem. Green's theorem is very one of the fundamental thing that you have to know, and it is it is important for very perspective that that you need to solve. And using Green's theorem you will be available to solve many interesting problems that will be very hard to solve otherwise. Okay, so we will discuss now Green's theorem. So let C be a simple closed curve in the plane. The positive orientation of C refers to a single counterclockwise traversal of C. That means this is a simple closed curve that C that is actually encloses a region D. Now a simple positive orientation means that you start from say this point, then you go like this, you track the entire curve, then once again you come back to this point only. So this is called a counterclockwise traversal of C, and this function D the region D will be bounded by left. See that the region is enclosed by the curve in the left only, not right. Okay, now what is your Green's theorem? So let C be a positively oriented simple closed piecewise smooth curve in the plane. So see, it is piecewise smooth, right? This is a piecewise smooth curve in the plane. Let D be the region bounded by C. That means C is the boundary of D. Delta D means boundary. If you have mxy and nxy have so if you have this mxy and nxy, you have continuous partial derivatives on an open region containing D, then this integration C m dx plus n dy, and just remember it that this is a closed integration. Okay, this is a closed integration. What does it means? It means a closed integration. That means the path integral is taken over the closed contour, this closed contour. The different name of a closed contour is actually the piecewise smooth curve. Okay, this piecewise smooth curve is actually means a contour. So just remember this theorem is very important if you are appearing for graduate aptitude test for engineering in mathematics or in any other branch of applied science, be it physics, or also if you want to pass the CSIR net exam, at least you can hope that there may be some problems, one or two problems based upon the three theorems which you will learn in this course. One is the Green's theorem, the second one is the Stokes theorem, and the third one is the Gauss divergence theorem. So today we will complete this Green's theorem part, and then if time permits we will proceed to the Stokes theorem part. So I am just once again reading this theorem, then I will go to the problem section. Let C be a positively oriented simple closed piecewise smooth curve in the plane. Let D be the region bounded by C, that is your C is actually the delta D, that means the boundary of D. And if you have mxy and nxy, that is continuous partial derivatives in an open region containing D, then I request you not to remember the second form, because it is just directly follows from the first only. So try to remember the first one only, but otherwise you can like fumble between the signs. So what does Green's theorem tells? Green's theorem tells that closed contour integration of m dx plus n dy is actually double integration of del n del x minus del m del y dA. Okay, that means Green's theorem converts a surface integration to path integration and a vice versa, a path integration to surface integration. We have not discussed surface integration till now, but we will discuss it just after a few moments. So this is the theorem. I hope that it is clear to you. Just you can like see the videos of Professor Kumar, and I think the theoretical and technical part is well discussed there. Okay, so I will not go into the proof and theoretical aspect of Green's theorem. I will upload the note in the NPTEL section, and from there on you can read. Okay, you can read, and you can in the comment section in the YouTube you can put your question. I will definitely try to answer your queries if any. So next we will move to the verification part of Green's theorem, that you need to verify Green's theorem for the field. Remember that Green's theorem works for two-dimensional vector fields only. So you have f equal to x minus y I cap plus x j cap, where C is a unit circle oriented positively. So here you have C is equal to RT equal to cos t I cap plus sin t j cap, 0 less than or equal to t less than or equal to 2 pi. So the region is D is nothing but the unit disk. So do you have remembered? So closed integration m dy plus n dx, this is equal to surface integration del n del x minus del m del y. This m dx plus n dy is surface integration del n del x minus del m del y, and then dx dy. This is just d of area. That means you are integrating over some area. Okay, so you have you are integrating over the closed circle, right? So on the unit circle, your x and y coordinate, they transforms into cos t and sin t, right? If you have ellipse, it would have converted into like your semi-major axis is A, semi-minor axis is B. Then your on the ellipse the vector RT will be, the position vector will be A cos t I cap plus B sin t j cap. And if you have a rectangular hyperbola, then that will be A sec t minus A sec t plus B tan t. Okay, so what is your x? Your x is now cos t, your sin y is now sin t. So your function mxy, that is x minus y, that will be cos t minus sin t. And what will be your n? Your n will be nothing but cos t, because this is just contains x. What will be your dx? Your dx will be minus sin t. Your dy will be cos t dt, because it is just you are taking derivative of cos t and sin t. Okay, so next you need to compute mx my and nx ny. So it is no need, just you can prove one only. There is no need to prove the second one. So you can, I have the proof, you can actually prove it as well. So your integration m dy minus n dx, your theta varies from 0 to 2 pi, m is cos t minus sin t, your dx is equal to your dy equal to cos t, your n is equal to minus cos t, then your dx is nothing but your x is cos t, so that will be minus t. We have minus t written, and then integration over dt, so that is equal to pi. Next you need to determine mx and ny. So your m is x minus y, so mx will be 1 and ny will be also be 1, 0. So then integration d 1 plus 0 dA. So that means you are trying to determine the area of d, and what is the area of the unit disk? Unit disk has radius 1, so area will be pi into 1 square, and pi into 1 square is nothing but again pi. So you observe that here we have verified Green's theorem. I hope this is clear to you, but still I am giving like 30 seconds. Just you just visually underscore whatever method I have utilized here, and this type of small problems will be very important for you, those who are we also appear for the NPTEL exam as well. Okay. Okay. So next is you need to evaluate the integral I equal to phi c cos okay, hello everybody, are you with me? Hello, are you
Yes,
with
sir.
us? Okay, there are some Saraswati Puja festival is going on in our IIT, so they are making some noise with mics. Is it disturbing you guys?
No, no, sir. Okay, sir. Here, sir.
Okay, so you hear clearly, right?
Here, clearly, sir.
Okay,
Clearly, sir.
okay, thank you. Okay, so I am continuing, right? Okay, so I am continuing. Okay, so you need to evaluate the integral. आप एक क्वेश्चन सॉल्व करोगे, इसको सॉल्व करो ना. इवेलुएट द इंटीग्रल I इक्वल टू फाइ c एक्स वाई dy plus y square dx, where c is the square cut from the first quadrant by the lines x equal to 1 and y equal to 1 with positive orientation. Okay, you need to evaluate this integral I equal to phi c x y di plus y square dx, where c is the square cut from the first quadrant by the lines x equal to 1 and y equal to 1 with positive orientation. Will you solve it? Okay, solve it guys, solve it, because it is a live tutorial class, so I hope that just solve this problem. So first you need to identify what is your m and what is your n. So your m is xy and your n is y square. So you need to c is the square cut from the first quadrant by the lines x equal to 1 and y equal to 1 with positive orientation. So your mxy is xy, your nxy is y square, and you need to determine this line integration. Square cut means you have 4 lines, x equal to 0, x equal to 1, y equal to 0 and y equal to 1, the square. Okay, सॉल्व करो इसे. Okay, so your mxy is xy, nxy is y square, your d is the region bounded by c. So what is your m dy minus n dx? Your m dy minus n dx, so you use Green's theorem, d mx plus ny dA, sorry, I think that there is a typo here, sorry, this will be m dy plus n dx, right? M dy plus n dx, that will be not a minus sign, that will be plus sign. I think there is a bit problem here. Just wait, check it me. Just give me time to check it. Your this is, you have your m is y square m dx. Your n is xy. M dx plus n dy. The second form is m dy minus n dx. Okay, m dy minus n dx, m dy minus n dx. Okay, m dy minus n dx, this will be minus this, that will be minus y square, sorry. Okay, I do not have sorry. Okay, just here is a bit typo. Okay, this mxy will be xy, or nxy you can use it in other ways also. You have, this is m dx plus n dy, your m is y square, okay, and your n is xy. So m dx plus n dy will be del n del x minus del m del y. There is this has a bit like, I think there is a bit typo. You just cross check it. Okay, this problem, I think there is a bit typo. You just follow my whatever statement I have given, and just try to solve it in terms of reducing it into this surface integration. Surface integration, here you will just need to do the double integration only. I have not like surface integration का भी अभी कुछ बात है नहीं, ठीक है? Is it okay? Is it okay to you? Please respond, anybody. There is a bit typo here, so I request you to please solve it in on your own. Theorem. Next, so you need to evaluate the integral I equal to 3y minus a की power sin x dx plus 7x 1 plus y की power 4 dy, and C is the positively oriented circle x square plus y square equal to 9. So see how Green's theorem is helpful for you people. You just observe, if you want to solve this problem using line integration, your life will be miserable. Your life will be very difficult to solve it in terms of like line integration only, because you have e की power sin x term, you have to need to integrate it. Okay, you have to use the substitution, because your x will be 3 cos t, y will be 3 sin t in the parametric form. But what happens in Green's theorem, since you are taking partial derivatives, the complicated terms will vanish. How it will vanish? See, it is 7x plus square root of 1 plus y square. So you have m dx plus n dy. So how will you write it? As del n del x minus del m del y, then surface integration. So what is your del m del n del x? You have to take derivative partial derivative with respect to x of this term. So you will get just 7. What is the partial derivative of this term with respect to y? Just 3. So 7 minus 3, 4. 4 into dA. 4 into dA means 4 into area of that circle. And what will be the area of this circle? You have radius 3. So 9 pi, pi r square is the area. So 9 pi and there is 1 4. So that will be 36 pi. Okay. Now you need to evaluate x की power 4 dx plus xy dy, where C is the triangle with vertices 0 0 0 1 and 1 0, and its orientation being from 0 0 0 0 to 1 0 to 0 1 to 0 comma 0. So this is our orientation. So now this line integration, you need to convert it into surface integration using Green's theorem, and then you need to solve it.
Sir. Hello.
Yes.
सर वो पिछले क्वेश्चन में वो बीच में प्लस लगाया हुआ है, इवैल्यूएट द इंटीग्रल,
इसमें
यस सर ये प्लस है बीच में
प्लस है, लेकिन हमने ग्रीन्स थ्योरम यूज कर दिया ना.
हाँ जी सर, उसमें तो माइनस हो जाएगा,
उसमें माइनस आ जाएगा.
यस सर.
इज इट ओके?
वही पूछ रहा, वो प्लस हटा दिया उसमें से फिर.
हाँ तो प्लस की जरूरत नहीं है ना, ग्रीन्स थ्योरम में माइनस आ जाएगा जे.
ओके ओके.
You have m dx plus n dy. So in Green's theorem you will get del n del x minus del m del y. हमने पार्शियल डेरिवेटिव का साइन लगा दिया.
यस सर वो पता है, हो गया.
ठीक है.
यस सर.
तो एग्जांपल 3.18 ट्राई करो. जस्ट ट्राई एग्जांपल 3.18. सिंपली यू नीड टू आइडेंटिफाई, एक ही फॉर्मूला याद करो. हाँ, इफ यू हैव m dx plus n dy, you need to just surface integration del n del x minus del m del y. Are you giving it a try? See, very simple problem.
Yes sir, yes sir.
Very simple problem.
सर 1/30 आ रहा है सर।
अच्छा, मुझे तो पता नहीं, मैं एक बार चेक कर लूँ।
यस सर।
ठीक है। गड़बड़ी हो गया। Okay, so you have m dx plus n dy. So what you will do? You will do del n del x minus del m del y. So that will vanish. You will have only y. You need to integrate first. See, one axis will vary, other axis will remain constant. So that means here what you will do, your y is varying from this axis to the straight line, and your x is sorry, yes, sorry, your y is varying from this straight line to this straight line, and your x is varying from here to here. So then it will comes as
1/6 सर। वो कैलकुलेशन में थोड़ा सा यहाँ पे मिस्टेक हो गई।
ठीक है, कैलकुलेशन मिस्टेक मत कीजिए। ओके, थोड़ा केयरफुली कीजिए। So this is del m del x minus del n del y. This is y dy dx. Now just you have to do the integration part, and that will just simply give you 1/x6. Okay, इसको ट्राई करो। Evaluate c x dy minus y square dx, where c is the positively oriented square bounded by the lines x equal to plus minus 1 and y equal to plus minus 1. कंप्लीट करो इसको।
सर यहाँ तो जीरो आ गया, ये तो जीरो नहीं आना चाहिए ना, जीरो आ गया सर यहाँ तो।
जीरो आ गया?
यस सर।
क्या हो रहा है आपके साथ? ओके, सो दिस इज योर, व्हाट इज योर, यू नीड टू, अच्छा ऐसे ऐसे मत करो, ओके।
1 - 2y तक तो कर दिया सर, उसके बाद ये 4 आ गया इनका, मेरा यहाँ पे मैंने वैल्यूज पुट करी, फिर उसके बाद
नहीं नहीं, वासी, फर्स्ट यू नीड टू आई सी 1 - 2y,
यस
ओके।
सर।
अच्छा एक सेकेंड रुको, एक सेकेंड रुको, हाँ।
1 - 2y स्क्वायर हो जाता है सर।
नहीं, 1 - 2y तो वो क्या आएगा, y - y
वाई
स्क्वायर।
स्क्वायर, अच्छा अच्छा, टू टू मैंने एक्स्ट्रा ले लिया इसमें सर।
2y है ना, ओके।
यस सर।
इज इट राइट, इज इट ओके नाउ?
यस सर।
यहाँ पे they have used the different formula, but also you, if you just use our main formula, you will also get the same answer. So what will be your m? Your m will be minus y square, and your n will be x. So del n del x minus del m del y will be once again, sorry, del n del x will be 1 my plus of it again, once again confused me. So m dx plus n dy will be del n del x minus del m del y. So your m is equal to minus y square, and your n will be minus x. So del n del x minus del m del y will be, your m will be minus y square, right? Now what will be your n? Your n will be, अच्छा आंसर आया है ना?
यस सर, आंसर तो मेरा यहाँ पे आया है, मैं एक बार फिर से कर रहा हूँ सर, देखता हूँ।
अच्छा एक बार वो वाला पुराना फॉर्मूला यूज करके देखो, देखो एक्स डी वाई माइनस वाई स्क्वायर डी एक्स है, ओके। सो व्हाट विल बी योर एम?
यस सर।
योर एम इज माइनस वाई स्क्वायर, एंड व्हाट इज योर एन?
यस सर।
योर एन इज
सर
x. So you will get del n del x, your del n del x will be 1 minus del m del y. Is it minus del m del y? Del n del x minus del m del y, yes. And minus del m del y will be minus del m del y will be plus 2y. यहाँ पे क्या प्रॉब्लम आ रहा है? अच्छा इसको एक और बार प्रॉब्लम को सॉल्व करो, हाँ। Since you have integration c is x dy minus y square dx, what is your m? Your m is minus y square, your n is, so what will be your King's theorem will be del n del x minus del m del y square, your n is x, so del n del x minus m dy minus n dx del n del x. Okay, I think there is a typo here. That will be 1 plus 2y, because your n is actually, if you still follow this, there will be no minus sign. Okay, this problem has also a mistake in this sign. Okay, I'll just solve. I am just sharing my screen. Wait a bit. Is my screen visible? Is my screen visible?
Yes, sir.
Actually, is my voice audible to you?
यस सर, आ गया सर, 4 आ गया सर, 4 है सर.
अच्छा, is my voice audible to you?
यस सर, 4 आएगा सर, 4 आ गया सर।
अच्छा देखो, ये 1 + 2y है, इसका इंटीग्रेशन होगा -1 to 1 -1 to 1, ठीक है। सो फर्स्ट यू नीड टू इंटीग्रेट विद रेस्पेक्ट टू, मान लो y के लिए तुम इंटीग्रेशन कर रहे हो, सो यू विल गेट y plus y² by 2. You need to put the limits from 1 to 1, then dx, then only you will get at -1 1, that is 1 plus half, that will be +1, and that it will be -1 dx. So that will become, ultimately what will be the answer? Your half will be cancel each other, so you will get -1 2 dx, and this -1 2 dx, that will be once again 2 1 plus 1 4. So I think answer was okay, but there was big typo, right? Okay, so it is clear now. I hope that it is clear, right? Am I or okay? So this is bit theoretical aspect. I request you to just read these problems. This is just theoretical problem. Okay, so next problem is this problem. You need to evaluate y². okay, मैं इसको हाइड कर देता हूँ. You need to evaluate c y² dx plus xy dy, where c is the boundary of the semi-annular region between the semicircles x² plus y² equal to 1 and x² plus y² equal to 4 in the upper half plane. ओके, इस प्रॉब्लम को ट्राई करो अभी. You need to evaluate y² dx plus xy dy, where c is the boundary of the semi-annular region between the semicircles x² plus y² equal to 1 and x² plus y² equal to 4 in the upper half plane. कर रहे हो ना? Are you trying to solve it?
Yes sir, yes sir.
Okay. इसको सॉल्व करो जल्दी।
सर 2/3 है कि 1/6 है?
द प्रॉब्लम इज दैट ओनली एक ही आंसर करेक्ट होता है, दोनों ही गलत है। 14/3 है।
अच्छा सर।
गड़बड़ी क्यों हो रहा है इतना? देखो अपर हाफ प्लेन में है ना, तो आपको 0 to पाई में इंटीग्रेशन लेना पड़ेगा।
सर मैंने 0 to 1 लिया है सर, एक्स बाउंड और वाई बाउंड।
अरे अपर हाफ प्लेन में थोड़ी ऐसे 0 to 1 ले सकते हो आप। यू नीड टू,
रेडियस।
ना ना अपर हाफ प्लेन है ना, दैट मीन्स द पॉजिटिव। फिगर तो यहाँ पे इलस्ट्रेटेड था। देखिए वाई स्क्वायर, सी का मतलब क्या है, सी ऐसे करके गया, फिर ऐसे ऐसे करके आके 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 ऐसे ऐसे करके, इसको स्ट्रिप कहते हैं, ठीक है। दिस इज कॉल्ड स्ट्रिप, एनुलर स्ट्रिप। तो वाई स्क्वायर डी एक्स प्लस एक्स वाई डी वाई। अरे इतना टाइपोस क्यों है इस नोट में, उफ। यहाँ पे भी टाइपो है, ठीक है। दैट विल बी एक्स वाई, मैं हाईलाइट कर देता हूँ। टेक्स्ट, सॉरी इसको ऐसे नहीं कर सकते। अरे यार इसको हाईलाइट कर देता हूँ। टाइपो, correct answer is correct is xy. So that will be del x of m dx plus n dy. So del x of, that will be m dx plus m dx plus n dy, m dx plus n dy, m dx. So your m is actually, n is actually xy, so that will be del x of xy minus, so that will be y minus, या तो शायद यहाँ पे आपको 3xy लिखना पड़ेगा इफ यू वांट टू करेक्ट विद दिस आंसर। सो इसको ऐसे करेक्ट कर देते हैं, ठीक है। इसको यहाँ पे करेक्ट कर देता हूँ, हाईलाइट टेक्स्ट, 3xy, इसको भी हाईलाइट कर देता हूँ, दैट विल बी 3xy, हाईलाइट टेक्स्ट, हाईलाइट टेक्स्ट, हाईलाइट टेक्स्ट, दैट विल बी 3xy. So that will be 3xy, del x of 3xy minus del y of y square. So you will get 3y minus 2y will be y dA. So now convert into polar coordinate. So in polar coordinate your r will vary from 1 to 2 and your theta will vary from 0 to pi. Is it clear? So that will be 1 to 2, r is varying from 1 to 2, theta is varying from 0 to pi, r sin theta, r dr d theta. Yeah, r dr d theta, this is called Jacobian. This r is the Jacobian. तो r sin theta, r dr d theta, इसको split कर लो. You split it, you will get r square dr 1 to 2 and sin theta d theta 0 to pi sin theta d theta. So if you take r square, that will be r cube by 3. So that means r cube 2 cube by minus 1 cube. That means 7 by 3. And from here you will get sin theta. The integration will be minus cos theta. And minus cos theta, so minus cos pi minus cos 0, so minus cos pi is 0 to pi sin theta, so that will be cos pi is minus 1. What will be your sin theta? आप इसको ना इस पे ब्रेक भी कर सकते हो. Why? Because these two parts are actually symmetric. और आप इसमें सरफेस इंटीग्रल कर रहे हो, तो यहाँ पे ये साइन थीटा के इंटीग्रेशन करोगे तो माइनस कॉस थीटा दैट विल कम एज जीरो, बट सरफेस इंटीग्रल कैन नेवर बी जीरो इन दिस रीजन. So that means you need to consider, you need to break it 0 to pi by 2, and sin theta if you break it from 0 to pi by 2 then there will be 2 multiply, so that will be 14 by 3, and sin theta will be minus cos theta, minus cos pi by 2 will be 0, and then minus cos 0 will be minus of minus cos 0 will be simply cos 0, that means 1. So that is why you will get 14 by 3. You need to break it into 0 to pi sin theta d theta. तो आपका तो आंसर करेक्ट आना चाहिए था, आपने 0 to pi by 2 तक लिया था ना, लेकिन उसके बाद 2 से मल्टीप्लाई करना था बस. Got my point?
यस सर, वो थोड़ा सा यहाँ पे रह गया, कुछ कैलकुलेशन में ही हुआ होगा शायद, देखता हूँ.
ठीक है, कोई बात नहीं. Okay, so one of the more important thing, okay, just one page I have left. I will not start new chapter in this today's class. I just discuss this part only. So in fact Green's theorem you can apply also to domains having holes, provided the domains can be divided into simply connected regions. तो आप इस पे क्या करोगे? First you will apply Green's theorem in this section, then you apply Green's theorem in this section. So you need to just break it into two parts, and then you can also apply Green's theorem. Just read it. I am giving 1 to 1.5 minutes, 1 to 2 minutes. Just read this statement, that what is the theorem trying to say. Then I have one problem for you. We will discuss that problem, and then we will today finish our class. यस
हाँ सर, नोट कर लिया सर।
ठीक है, नेक्स्ट आई विल मूव टू दिस प्रॉब्लम। अच्छा, ये थोड़ा टेढ़ा मोड़ा प्रॉब्लम है, लास्ट ईयर भी थोड़ा बच्चों को दिक्कत आया था इसमें, थोड़ा ध्यान से देखना। हाँ, so that if C is any positively oriented simple closed path that encloses the origin, then minus y by x square plus y square dx plus x by x square plus y square, यहाँ पे there will be dy x dy by x square plus y square, this you need to show as 2 pi. No idea how to show it for every such curve, so take a positively oriented circle C of radius a around origin that lies entirely in the region bounded by C. So let D be the annular region bounded by C, and C, this is C and this is your C prime and this is your D region. Okay, then what is your vector? Your vector is minus y I cap plus x j cap by x square plus y square, because you are ultimately determining f dot dr, and that f dot dr will convert into m dx plus n dy, and then this will be upon C plus this orientation will be, you need to consider in the reverse direction, right? As in the theorem, you need to consider in the reverse direction. Next, this will be annular region D, nx del n del x minus del m del y dA. This will be give you 0. Why? Because here your vector f is mi plus nj. This will gives you nx my equal to y square minus x square by x square plus y square whole square. Then m dx plus n dy, this becomes simply m dx plus n dy in the this C prime, but C prime is parameterized by xt equal to cos t and yt equal to sin t. So if you this m dx plus n dy, you need to put it here 0, 2 pi f of there will be no a, there will be simply this f vector, you need to replace it with a cos t I cap, sorry, there will be no a, there is also one typo, these are not to be considered, and then you will finally get the answer to be 2 pi. Okay, okay, this problem na, I think something is missing. I think there will be one more extra page in this note. I have missed it to add, I think. Okay, so till now whatever I have discussed, do you have any question, anything, any question you want to ask?
No sir, all is clear sir.
Clear?
Yes sir.
Okay. So thank you for today joining. नेक्स्ट क्लास में भी थोड़ा जल्दी ज्वाइन कर जाना, हाँ 6 बजे के अराउंड ज्वाइन कर जाना, नहीं तो टाइम वेस्ट हो जाता है, ठीक है?
ओके सर,
थोड़ा जल्दी ज्वाइन कर जाना। थैंक यू प्रतिभा मैम फॉर ज्वाइनिंग, विनय, एवरीबॉडी, एस सन्मुगम सर, थैंक यू फॉर ज्वाइनिंग।
Thank you, sir.
थैंक यू। नेक्स्ट क्लास में भी प्लीज ज्वाइन इन द नेक्स्ट क्लास ऑल्सो. We will start around sharp 6 o'clock only, 6 o'clock. Hope that you will join in the next class also. Thank you very much. So the note is already updated in my NPTEL Google Drive. From next class I will start discussing Gauss divergence, curl and all, and then surface integration. Okay
okay sir.
Bye.